So now that we've looked at the various net zero methodologies, we go on to explore how to account for the various greenhouse gases. So, greenhouse gas accounting is defined as the process of calculating the carbon footprint of a service or a product and breaking these into the different types of greenhouse gases like carbon dioxide or nitrous oxide or methane. So to analyze greenhouse gas emissions, then you can use a software or a spreadsheet to have an inventory of the various greenhouse gases, which is called the greenhouse gas inventory. Now, a number of standards are available to use to calculate the greenhouse gas accounting or the greenhouse gas inventory. For this course, we explore majority from the greenhouse gas protocol. So the fundamental steps in calculating greenhouse gas emissions include initially identifying the sources of emissions, looking at the various types of greenhouse gas emissions and the sources. And then the next step is to select what calculation approach or method will be used. So the next step also is to collect all the relevant data and choosing the emission factors that will be used. A number of organizations provide different emission factors. So for consistency, you choosing which emission factor database will be used. And then the next step is to apply the calculation tools, either spreadsheet or software. Completing the process is to roll out the data across the organization. So we take a deep dive into the scopes of emissions across the value chain. So what we have here is there are three main scopes of emissions. Now, scope 4 is being talked about at the moment, but currently the most widely accepted three types of scopes are scope 1, which is the direct emissions, scope 2, which is indirect emissions, and then scope 3, indirect emissions. So what we have at the top are the number of greenhouse gas emissions like carbon dioxide, methane, nitrous oxide, for example. And all these emission sources are emitting the different types of greenhouse gas emissions. Now, we have carbon dioxide, and then you tend to have carbon dioxide equivalent, which in the calculation procedure, there is a process of converting the different types of greenhouse gas emissions into a carbon dioxide equivalent. So when you see CO2e, that's what it stands for. So from a scope 1, which is the direct emissions from the company's owned vehicles and the fuel combustion within the company, which is the direct emissions within the company. Scope 2 is to do with the purchased energy for the company. So the purchased energy for the company will fall under scope 2 emissions. Scope 3 is the indirect emissions, which would be from the value chain and the supply chain, which will be from the value chain or the supply chain. And these are some of the examples of activities. So the product usage, the production of the purchased materials, outsource activities, contractor owned vehicles, waste disposal, employee, business, travel. Now, all of these will be under scope 3 emissions. Explore from this source to get further insight into the various scopes. So what we have here is the number of greenhouse gas emissions from carbon dioxide, methane, nitrous oxide, and the fluorinated gases, also known as F gases. So we have some of the potential sources. So for example, carbon dioxide, you have the combustion of fossil fuels. Methane, for example, the processing and distribution of natural gas in other agriculture processes. Nitrous oxide, you have fertilizer as an example, and F gases, you have the refrigerant leakage as an example, or other fire suppression systems. So what we're showing clearly here is the global warming potential for the various greenhouse gases shown here. So we can see methane has a higher, nitrous oxide is higher than methane, and the F gases can range up to thousands. And then you have the number of time the means atmospheric residence time, how long the emitted greenhouse gas emissions would stay within the environment. So we have methane well around 12.4 years, nitrous oxide 121, and then the F gases can be thousands of years. Carbon dioxide between 65 and 80% of CO2 released into dissolves into ocean over a period of 20 to 200 years. So we can see the various ranges and comparison between how long emitted greenhouse gas emissions can stay within the environment and how impact the global warming. So this source is taken from the IPCC report. So further, similarly from the IPCC report, this is just to show the quantity and breakdown of the greenhouse gas emissions. So previously we saw, for example, the residency time and the global warming potential of other greenhouse gases like methane and nitrous oxide was more than the CO2 emissions. But we can see that one of the reasons why the CO2 emissions is highly focused is because of the quantity of emissions between 1970. So this is what we have here is the emissions between 1970 and 2010 and the number of greenhouse gas emissions. We can see that the CO2 emissions is higher compared to the other greenhouse gas emissions. Nonetheless, the other greenhouse gas emissions are significant in terms of reducing the emissions coming from these sources. So what we have here is showing the anthropogenic greenhouse gas emissions. Now, anthropogenic is a scientific term highlighting the human-caused greenhouse gas emissions because there are other natural emission sources. But the main focus of net zero is what activities of humans is significantly impacting the various emissions. The breakdown in terms of economic sectors, again, we can see energy or the direct emissions shown here and then indirect emissions. So when it comes to the direct emissions, then you have electricity as one of the major parts, agriculture, food, land being one of the major parts. Then you see transport and then buildings, industry, and other energy. And then you have the breakdown of the indirect emissions. Again, you have the buildings. So we can see if you look at the direct emissions, buildings is 6.4%, but from an indirect emissions perspective, then building is 12%. So again, this is highlighting the breakdown of emissions. So what we have here again from the World Resources Institute source shown here for further exploration, then this tries to break down the various sectors. So from energy, the breakdown in energy, which is used in buildings, but this is to 2019 data. The purpose of highlighting this is the breakdown in terms of end use. So from heat and electricity, what are the typical activities that are used? And then from transportation, what are the typical activities that are used? And so on and so forth to industrial, agriculture, waste. So we can see the key activities that are used and the greenhouse gas emissions emitted. So we can see again CO2 being one of the significant. I know that's 2019, and the purpose of highlighting this is the typical activities that are causing the greenhouse gas emissions. So that's the fundamental focus of this graph. So we look at what are the key steps in setting greenhouse gas targets. So we have from the source, these are the fundamental 10 steps. So again, starting from gaining the senior management commitment and then deciding what is going to be the base target which will be used. Is it going to be from absolute or based on the various intensity? And then decide what is going to be the boundary of the organization or the country where these greenhouse gas emissions would include. How far within the organization? Is it just going to be the offices or going to be the operations? or the emissions is going to cover the value chain. And then choose a base year, which will be compared to, let's say, 2022 or 2019. And then defining the key completion dates, the long term by 2050 or say short term by 2030. And then define the length of the target commitment period, and then decide on the use. Are you going to use any offsets or carbon credits? And again, establishing a target double counting policy to minimize any double counting and how to deal with these. And the ninth one is deciding on the target level compared to a trajectory. Is it compared to business as usual or compared to what's in the industry? And then tracking and reporting the progress to various stakeholders. So this is how to calculate greenhouse gas emissions. Then you have determine what the operations is and then identify the emission factor. So you multiply the activity within the operations by the specific emission factor to get the total emissions. So for example, the activity or the operations emit 250,000 megawatts hours of energy, then the emission factor is zero point 0.2 tons of CO2 equivalent per megawatt hour. Then the how to calculate the greenhouse gas emissions is multiplying the emission factor by the amount of energy to get the overall emissions, in this case 50,000 tons of CO2 equivalent. So that's an example of calculating a greenhouse gas emissions. So there are a number of sources of emission factors and databases. Different countries, some countries from a national level may be providing these emission factors that may be used. But from the sources from organizations, then the IPCC, the Intergovernmental Panel on Climate Change, has a database for emission factors that companies and countries may use. And also, the Greenhouse Gas Protocol standard also provides sources around the emission factors and other calculation tools. So explore the Greenhouse Gas Protocol website to use some of these calculation tools.